Today the agenda is a brief introduction to Oracle 12c RAC. Uh, okay, I'm sure everybody in this session has basic idea about a RAC. Let us quickly see the concept of RAC. So what exactly is RAC? Everybody knows this. It is basically an option of Oracle database server that allows you to run multiple instances against a single Oracle database. So RAC is basically an option of Oracle database. It's not a separate software. It's not a separate entity. It is part and parcel of your Oracle database. Only thing is, it requires a separate license. So from a software perspective, the same software, the database software, the same binaries. Okay, but only thing is, the RAC option allows you to have multiple instances for your database, as shown in this slide. So this is what we know. This is what you have been handling so far. A regular database, a single instance database, in which a database will have an instance, a single instance. And in RAC, this is how it looks like. The same database having two or more instances. Two or more instances. So in simplest terms, this is what exactly is RAC, a database with multiple instances. So what is the advantage of having multiple instances? Okay, so to understand that, let us first understand the working of single instance database and the shortfalls or the drawbacks in single instance database. Now, I have a single instance database installed on a server. You know, database is on the storage and instance is in memory. And everything, anything goes through instance, right? Users and applications connected to instance to access the data from the database. So that way, instance acts as the gateway between user and database, between application and database. Without instance, you cannot access data present in the database, right? Now, this single instance database requires a single server, a standalone server. So in this scenario, there are clients, database clients, which are connecting to the instance and accessing the data from the database. Now, what happens when this instance fails? What happens when this instance fails? All the connected clients, all the connected applications, right, lose the connectivity. There is no way to access the database now. So that is the problem in single instance database. Whenever instance fails, all the clients will lose the connectivity with the database. Why would instance fail? Could be many reasons. A software bug in Oracle may cause instance to crash, or memory corruption, because instance runs in memory. If memory fails, memory is a hardware device. Memory may fail, causing instance to fail. or power failure. Of course, this is very unrealistic. In real time, we'll have power backup, but that could be one of the reasons. Sometimes the power backup may not work, so it may cause fluctuations, right? So anything in the memory is gone. So whatever may be the reason, when the instance fails, all the connected clients will lose the connection. There is no way to access the data now. So technically you say your database is not available for business now. So if you are on a tight SLA, you are not meeting that SLA for high availability. This is one drawback, right? Next problem could be, again, the same server, same clients connecting to the instance and accessing the database. Now this time entire server failed. Right? Again, there could be many reasons. Hardware failure, data center failure, any disaster which caused the server failure, or there is a fire accident in the server room, the server has gone in fire, right? Or there is any hardware problem which stops the show. So again, the same problem. All the connected clients lose the connection. They are disconnected, and now you say your database is not available. So these are the two main drawbacks. These are the two main drawbacks in single instance database. When the instance fails, when the server fails, your database is not available for transactions. So if it is mission critical database, if it is business critical database, your business objectives cannot be met now. You are not meeting your SLA for database availability. Another drawback or another shortfall in single instance database is you have only one instance, right? And every instance has capacity, sizing, right? As how much load it can bear, how many connections it can have, concurrent connections. For example, in our scenario, this instance capacity is, it can have say 1000 concurrent connections, right? Now what happens if more than 1000 concurrent connections comes? So this instance cannot bear that load because you have only one instance and it has fixed capacity. Maybe you may say I may add memory to the server and then increase the instance size. But ultimately every server again has, right, have the limit on how much memory you can install on a server. Once that limit is reached, you cannot increase the memory size, meaning you cannot increase the instance size. So if your workload is fixed, you know the workload and almost it is fixed, it doesn't increase, then maybe single instance database is okay. But if your workload is not fixed, every day it keeps on changing, like in the case of web applications, you never know how much workload will be there on the instance in a given day, on a given day. So one day you may have 1000 connections, another day you may have 5000 connections, another day you may have 50 connections. So the workload, not only connections, the workload, keeps on changing. So that is the second drawback. So both these drawbacks, can be technically termed as the first one, high availability. Whenever instance fails, your database is not available. Whenever server fails, your database is not available. So that is availability problem. You don't have high availability with a single instance database. And the second drawback is you don't have scalability. These are the points shown on this slide. To summarize, the shortfalls, the drawbacks in single instance database are: one is it doesn't provide high availability, meaning instance failures, server failures make your database unavailable for transactions, unavailable for your business. Second drawback is scalability. Single instance database doesn't provide scalability, meaning it has fixed capacity, it supports limited workload or fixed workload. If the workload increases, the database cannot support that. So these are the primary drawbacks, okay, shortfalls in single instance database. Now, let us see how RAC overcomes these shortfalls. So now we will see working of RAC with similar diagrams. Now, before that, let us see RAC hardware. What is required to implement RAC? You know, to implement a single instance database, you need a single server, standalone server. Whereas to implement a RAC, you need a cluster with a shared storage. So what is cluster? Cluster is group of two or more servers. Grouping of two or more servers acting as a single server to the application. So that is cluster. And with shared storage. Okay. So every server, when you say server, every server has memory and storage, internal storage. But all these servers need shared storage. They access some shared storage. As shown in this diagram, I have one server with local memory and local storage. I have second server with its own memory and disk space, that is storage, right? Now, these two servers are logically grouped using some software. Okay, physically they are different servers, but logically they are grouped with some software. So this is called a cluster, group of two or more independent servers acting as a single server to the application system. So we use a special software to implement a cluster. That software is generally called as clusterware. Clusterware. Right? There are many clusterwares available in the market, and few clusterwares are certified for RAC implementation. Okay? And Oracle has their own clusterware called Oracle clusterware, which is a required clusterware for RAC. Okay? So we will see the software details at a later stage. For now, just understand that group of two or more servers is called a cluster. Now, is it just two, or you can have more servers? You can have more servers, minimum two servers in the cluster. Otherwise, you call it as a standalone server. Now, you can add more servers as required. How many servers depends on the clusterware that you use. If you use Oracle clusterware, which is a required clusterware, Oracle clusterware supports up to 100 servers in the cluster. 100 servers in the cluster. that is up to 11G. In 12C, the story is different. 12C introduced a new type of cluster called flexi cluster. In flexi cluster, a cluster can have more than 100 servers. Okay, probably you can have thousands of servers. So up to 11G, Oracle Clusterware supports 100 servers per cluster. That is called as standard cluster. So all the RAC clusters up to 11G are called standard clusters. 12C also has standard cluster in which you can have 100 servers, 100 nodes per cluster. 12C also introduced a new type of cluster called flexi cluster. In flexi cluster, you can have more than 100. Okay, you can have thousands of servers in the cluster. So we'll talk about all these things in future classes, but for now, remember that in 12C, you can implement two types of clusters, standard cluster or flexi cluster. Standard cluster can have 100 servers per cluster. Flexi cluster can have more than 100 servers per cluster. Now, this is just not enough for your rack. So this is your cluster, but apart from this cluster, we need a shared storage, which is an external storage, which is shared among all the servers in the cluster. Every server in the cluster can access this shared storage. So if you create any file on this shared storage, it is visible to every server in the cluster. You can access that file from any server. So that is the concept of shared storage. So from a hardware perspective, this is what you need to implement a rack. You need a cluster with a shared storage. Now, having understood this, let us see how rack instances work. In rack, the database will have multiple instances. Each instance runs on physically different server in the cluster, and the database is created on the shared storage. So this picture summarizes that. Now we have two servers in the cluster. Each server is also called as a node. Individual servers are called nodes. So I have two nodes in the cluster, node 1 and node 2. Each node or each server has its own memory, its own internal storage, hard disk. And both these servers, both these nodes are attached to shared storage. Right? Now in this diagram, we have created a RAC database on the shared storage. Okay? And we have created instances, two instances on different servers, on both the servers. Now, this is the typical RAC diagram. You have database on the shared storage. You have individual instances running on different servers in the cluster. Now, let us see how this architecture provides you high availability and scalability. Now, instance failure. Let us see how RAC handles instance failure. Again, we have the cluster with the shared storage, database created on the shared storage, having two instances running on two different nodes in the cluster. Now in this scenario, your database has two instances. Clients may connect through any instance, right? Now, for example, I have one client connecting through the first instance. Another client connecting through the second instance from the second node. Now, in this scenario, there is some instance failure. Say my first instance failed, right? So what happens to your database? What happens to clients? First of all, when this instance fails, right, who are affected? Only the clients that are connected to that failed instance. Okay. Now, your database is still running. Remember, your database is still available because you have another instance through which clients can access the database. So technically, your database is available for business. It is not completely inaccessible. It is accessible now. It is available now. Only thing is the clients that are connected to the failed instance will have impact. Now, this also can be remediated. Now, when this instance fails, this client can be redirected to the surviving instance, the other instance, so that they continue to access the database. In fact, this redirection can be automated in RAC. Okay, when an instance fails, the client connections can be transparently moved to the other instance, transparently failed over to the other instance. That way, clients doesn't see any interruption. When an instance fails, they continue to access the database without interruption. So that way, instance failures can be masked from clients. Clients continue to access the database. When you say database is not available in RAC, when all the instances fail at the same time, which is very remote chance, right? Because each instance is running on a physically different server. At least if one instance is there, technically your database is available. That is it. Now server failure. Similarly, instead of instance failure, there could be server failure also, entire server failure. Right? Again, the same diagram, same clients connecting through different instances. Now this time entire server failed. No problem. Again, you will direct the clients to the other instance. Okay. So that way, with RAC, you can have high availability. RAC provides you high availability against instance failures or server failures. Scalability. Because RAC has more instances, more and more workload can be supported. Right? Each instance has some capacity. So now in single instance database, you have single instance which has some capacity. In RAC, suppose if you have two instances, you will have double capacity. If you have three instances, you have triple capacity. As you need more capacity, as your workload is increasing, you can add more servers to the cluster and create additional instances. Both nodes have the same data or different data. See, in RAC, the database is same. Means all the database files, the data is same. Only thing is this data being accessed through multiple instances at the same time, parallelly. So you have the same set of data. You still have single database. Yeah. Then added to this, you can better manage your workload in rack environment because you have more than one instance. You can assign an instance to a particular workload. For example, I have transaction workload. I will assign instance once to transaction workload. I have reporting workload. I will assign instance to reporting workload. I have batch workload. I will assign instance 3 to batch workload. So that way, as you have more instances, you can dedicate each instance to a particular kind of workload. Or geographically, suppose I can assign first instance to US traffic, second instance to Middle East, third instance to Europe. Like that, you can dedicate each instance to a particular workload or the workload coming from geographically different locations. So that way, you can have better workload management when you have more than one instance. So this is how you benefit with rack.
Yeah, hi Murli.
Yeah. Yeah, please go ahead. Who is this? Okay.
Yeah, Murli, in that case, if yeah, Ravish this side.
Yeah, Ravish.
Yeah, if we divide different instances on different job role,
Yeah.
if suppose one instance is serving the transactional the whatever the transactions is there online transaction, it is
Yeah.
handling that, and other is handling the my reporting server, and one is for batch processing.
Yeah.
If suppose my the instance which is handling the transaction, if that gets failed,
Yeah.
and I have a three instances running,
Right.
then
Yeah.
what will happen?
Yeah, that is in fact technically good question. See, though you dedicate an instance for a particular kind of workload, if that instance fails, what happens to that workload? You can choose another instance as a backup instance. Okay? Meaning when that main instance fails, this workload can be handled by another instance, which is called available instance. We use some concept called services to achieve all these things. We define services, right? Suppose I will define transaction service, OLTP service, which runs on first node, first instance. Okay? Now, this service will have a backup instance. When this backup instance runs this service, when the main instance fails. Now, OLTP service is running on instance 1. And when I created OLTP service, I designated instance 2 as the backup. Now, when instance 1 fails, the OLTP service will be started on instance 2 so that your OLTP workload goes through instance 2. Right?
Okay.
So that way
Yeah.
you can still have backup instances which can handle the work when the main instance fails. So in
So
RAC terminology,
the
we call them as preferred instance and available instance in RAC
so
terminology.
in that case, whenever my instance got failed, so it automatically gets shift like we used in RHL, Red Hat cluster.
Yeah,
If my one node fails,
yeah,
then automatically the service will shift to the standby
correct,
node.
correct. This is transferent to the application.
It is a okay. So here also it is the same concept.
Correct, same concept. It is transferent to the end user.
Okay.
End
Thank
user
you.
never knows that that instance failed and their connection has been moved to another instance. In fact, we will be
Okay.
implementing this in our course also. We will be technically verifying that, practically verifying that.
Okay, and one more thing,
Yeah.
if suppose I have a two instance, then is there any load balancer from the application side which will divide the load on the instances, or it is internal to rack?
Um, See, if it is web application, definitely you will have load balancer, right?
Okay.
And if you are not using any web server, RAC
Okay.
also has load balancing feature. RAC has
Okay.
something called a scan. Scan has scan listeners. So you can configure
Okay.
load balancing for RAC. So whenever connection request comes, it will load balance this request among available instances. Okay. So
Okay.
to summarize this, RAC has inbuilt load balancing feature. Whether you use external load balancer or not, RAC has inbuilt load balancing feature. Yep.
Okay, Wally, thanks.
Yeah, sure.
Hello.
Uh, Saqib, how do I speak? Um, just you can speak over the microphone. I hope you have microphone to your laptop or desktop or mobile phone. You can just speak it out and we'll listen to you. Saqib.
Using my microphone. I attempted to speak a couple of times, but I don't think you can hear me.
Yeah, we could hear you now, but it is a little bit low voice. Can you be a little bit louder?
Okay, I'll try. Murali, if you go back uh, to the last slide, yeah, just didn't understand what server failure means in the context of rack. I mean, when the database is stored in a separate storage, shared storage.
One minute, Saqib. Sorry to interrupt you. I am still not able to hear you
Just wanted to understand
properly.
what server failure is.
Others, can you hear Saqib, or is it with me only problem?
Yeah, Murali, it is audible. What Saqib is telling, he want to know what is server failure.
Yeah, entire server may fail. There may be a hardware failure in the server. Suppose motherboard, system board failed on the server, entire server is down, right? Or any other hardware failure which makes the entire server unavailable. Sometimes a component may fail, sometimes entire server may fail. Agree? Suppose CPU failure is a component failure. Memory failure is a DIMM of the memory failed. It is a component failure. Suppose system board to fail. Now you have big problem. So on a server, a component may fail or entire server may fail. Yeah, I hope I answered your question, Sakir. Is that what you are looking? Database is stored on separate storage. Yes, correct. So in this diagram, if you see, when we create a database, we choose the external shared storage location to create the database files, like your CRD files, control file, read log file, data files. We will keep it on the shared storage. So shared storage will be exposed to all the servers, okay, through some interface name, right? Like U01, U02. Suppose maybe U01 is local hard disk, internal hard disk, and the shared storage is exposed to OS as U01, U02, sorry. Then does a server's own storage have? Yeah, each server will have its own storage, internal storage. but that storage is not used for database creation. That storage is used for operating system installation, then the clusterware software installation, then Oracle binaries installation. Only binaries will be installed on the local storage of the server. When it comes to database installation, database creation, you will create the database files on the shared storage. Because in RAC, all the instances sharedly access the same database, right? So database is shared among all the instances. So that is why the database should be on the shared storage. Yep. Sure. Thank you. Any more questions from anybody? No? Okay. Fine. So if no questions, let us move forward and see more details about RAC hardware. Major components of a RAC system. Now when you implement a RAC system, you have some major components. Of course, cluster. By now you understood cluster is the main thing in RAC. So a cluster is required to implement a RAC. Whenever a cluster is there, you need a software. And Oracle clusterware is the required software to implement a RAC. Then shared storage, right? So cluster is not enough for RAC. You also need shared storage. Then cluster interconnect, which is nothing but the network. Okay. Though you have physically different servers in the cluster, these servers communicate among themselves through some network, which is a private network. That is often called as cluster interconnect, which is a private network used by each node to communicate with other node. So in the RAC, there is a lot of communication, lot of data transmission from one server to another server. Many messages will be exchanged between the servers for the synchronization. So for all that communication, for all that data transmission among the servers, we need a network, okay, that is called interconnect. That is called cluster interconnect. That is another component. The last one is, of course, the RAC software, which is nothing but your database server with a RAC option, license. Okay, RAC is separately licensed option. So these are all the major components of a RAC system. Now we will understand more about each component, the requirements about each component. First one is cluster. Now by now you know a cluster is group of two or more servers acting as a single server. Now when it comes to RAC, what is the criteria? Every server in the cluster should run the same operating system and same processor architecture. Of course, nowadays with the 12C it is all 64-bit okay, hardware, no more 32-bit. If you are running 11G, you still have the option to choose 32-bit hardware. Okay. So two key points are every server should run the same operating system and same processor architecture. That is the requirement for the cluster. Next, Oracle Clusterware. This is the software which implements the clustering, which groups the physically different servers into logically single servers. So Oracle Clusterware is the software that implements the clustering. Now, in this diagram, I have a cluster, right, with the 2 nodes. Every node has its own memory, its own local storage. So Oracle Clusterware implements the cluster, binds all the nodes together in the cluster, and it is required for RAC. It is compulsory. Without that, you cannot implement a RAC. And it is installed on every node in the cluster. So in fact, before installing Oracle RAC, you need to implement a cluster. You need to have 2 servers. You need to install operating system on each server. You need to install Oracle Clusterware on each server and implement that cluster. Then only you can install Oracle RAC. Now in this diagram you can see the Oracle Clusterware is installed on every server, on the local storage of every server. Okay, so if you have 10 nodes, you will be installing operating system on every node, every server. Similarly, Oracle Clusterware should be installed on every server on the local storage. But technically, you will start one instantiation of the installation. You will start installation on the first node maybe. So the installation program will automatically copy the software and install on every node. So you don't need to install 10 times. With one instantiation, you can have the installation on every node. Then shared storage. So now we have cluster with the clusterware installed and the cluster implemented. We need a shared storage. We need shared storage. The shared storage is shared among every node in the cluster. Okay. So what is the use of the shared storage? The shared storage is mainly used for creating Oracle database, the RAC database. Okay. Oracle Clusterware also stores some files on the shared storage. So your Oracle database files, Oracle Clusterware files are created on the shared storage. And this shared storage should be cluster aware storage, meaning it should allow access from every node in the cluster. Any node can access any file. Multiple nodes can access the same file at the same time. So that is what is required. Okay, and the storage can be any of this. It can be a directly attached storage, DAS. It can be NAS, it can be SAN, or it can be an NFS storage. Most commonly we use SAN storage. Okay, SAN is the most commonly used storage technology. Must be configured. This shared storage must be configured with a cluster file system, okay, or Oracle ASM, which provides cluster file system. You cannot implement regular file system on the shared storage because the regular file system allows only one node to access the files. But here multiple nodes will access the files on the shared storage. So to allow that concurrent access from multiple servers, you need a cluster file system. right? And Oracle also has their own cluster file system in the form of Oracle ASM. So you can use CFS or ASM. Of course, ASM is the most commonly used, okay, file system for shared storage. In this course also, we will be using ASM. If at all you want to use cluster file system, there are many cluster file systems available in the market. Of course, many of them requires a separate license. You have to purchase license and use them. Whereas Oracle ASM doesn't require license. So that way you can cut down cost when you use Oracle ASM for shared storage. If at all you want to use cluster file system, few of them which are supported certified for Oracle RAC are shown in this slide. HP Service Guard extensions for RAC. Okay, this is a cluster file system from HP. Then IBM has a cluster file system called GPFS, General Parallel File System, supported for RAC. Solaris cluster file system, supported for RAC. Veritas Storage Foundation for RAC. These are all certified for Oracle RAC, and they all require separate license. You need to purchase a license to use these cluster file systems. And Oracle also has a free cluster file system, Oracle Cluster File System, OCFS. Okay, the latest version is 2, OCFS 2. Okay, Oracle also has ASM, of course. Okay, so these are all the choice for cluster file systems. Instead of cluster file system, Oracle always recommends you to use Oracle ASM because there are many advantages with Oracle ASM, and many customers in the field use Oracle ASM. In the course, in the lab also we use Oracle ASM. Next component is cluster interconnect. As I told you, cluster interconnect is nothing but a network which connects all the servers in the cluster, which allows a server to communicate with other server in the cluster. This network is often implemented as a private network, which is available only to the cluster nodes. Now you see in the diagram, this red line is your network, which connects node 1 with node 2, which allows node 1 to communicate with node 2, which allows node 1 to exchange data with node 2, or which allows node 2 exchange data with node 1. Right? So it is a private network which connects every node with other nodes in the cluster, which allows every node to communicate with other nodes in the cluster. So when you implement a RAC, RAC has some concept called cache fusion. For cache fusion, RAC also uses cluster interconnect. So cache fusion is nothing but simply a data block from one instance can be transferred to another instance over interconnect. Okay, so that is the concept of cache fusion. A data block in one cache, one instance cache, can be transmitted to another instance cache over the private network. So for that also RAC uses interconnect. This interconnect, this private network, should be high bandwidth and low latency, because otherwise if this private network, if this interconnect is slow, it will cause performance bottlenecks in the system. In fact, this is one of the major component which need to be looked at during RAC implementation. So if your private network has low bandwidth, high latency, your RAC system okay, will cause performance bottlenecks. The minimum recommended bandwidth is 1 Gbps. Okay, it should be minimum of a Gbps network. So the more bandwidth, the better, so that data transfers, communications happens in a quick time. Finally, the last component is the software, the Oracle database server. As I told you earlier, RAC is not a separate software. The binaries are database binaries only, because the RAC is an option of database which is separately licensed. So you install the database binaries with RAC option, and these binaries are installed on every node in the cluster. Like earlier, we installed clusterware on every node as shown in this diagram. Similarly, okay, you install RAC database binaries on every node in the cluster, and this is used to create the RAC database which is on the shared storage. So these are the major components of RAC system, and few more details about each component. Now, one component which needs special attention in RAC is networks. RAC implements multiple networks. Okay, so that's why it needs special attention. So let us see the networks in RAC. In fact, RAC uses minimum two networks. Minimum two networks. One is called the public network, which is used by clients to connect to the RAC database. So public network is nothing but your LAN. Your RAC servers, your cluster nodes are connected to LAN using public network. So all the clients access the RAC system using public network. Similarly, apart from public network, as we just discussed, RAC also uses private network, which is also called as interconnect. So private network is private to the nodes in the cluster, accessible to only nodes in the cluster, used by the nodes in the cluster to communicate with other nodes. RAC uses private network for cache fusion. So whenever you want to implement RAC, you need to plan for minimum two networks. Of course, 12C. In 12C, there is another network introduced, which is, though optional, you can have a third network when you are installing 12C RAC, which is called ASM network. Okay, up to 11G, ASM instances, when you implement ASM storage, ASM instances on every node also uses the private network for their communication. But in 12C, Oracle has separated ASM network, has given the option to have a separate network for ASM instance communication. So you can configure a third network, which is called ASM network, which is used by ASM instances to communicate with other ASM instances in the cluster. If you don't want to implement a separate network for ASM, you continue to use the private network for ASM also. So that way in 12C, you can implement up to 3 networks. Minimum required are 2. So as shown in this diagram. Now again see the cluster with the 2 nodes. So every node should have minimum 2 NICs, network interface cards, the Ethernet cards, which allows networking, right? Now, both nodes has two NICs, NIC1, NIC2. Now, NIC1 is going to public switch. So, NIC1 is used to implement public network. So, they are going to public switch. And any client in the network access the cluster nodes through public network, right? So this is the public network. Apart from public network, okay, a rack also has private network as shown in this diagram, the red one. NIC2 implements private network. It is going to another switch which is private, which is not connected to the public network. So this is private network, which is used by the nodes in the cluster to communicate among themselves.
Yeah. Murli,
Yeah.
by private switch private network, you mean to say that is a rack chassis switch?
Sorry, which switch?
Basically, we'll use chassis.
Chassis? Well, I'm sorry, I didn't understand that.
I mean to say by that private network, the switch that you are using
Yeah.
is inbuilt in the chassis, in the hardware
No,
itself.
no. It is another switch, external switch. Only thing is, this switch is not connected to LAN. Whereas this switch is connected to LAN, so that any LAN client can access these servers through this switch. Both are external only. Both these switches are external switches. They are not inbuilt. Only difference is the public switch is connected to LAN. Private switch is not connected to LAN. So LAN clients cannot use private network.
Okay. And then one more question I have is
Yeah.
that node 1, node 2, that is basically blade servers.
Yeah, you can use any type of server, though blade server is the standard in today's world. Blade servers, or you can use regular servers, tower servers, okay, any server of your choice. Of course, blade server is common in data centers nowadays because of the form factor. Okay, so otherwise you can have any type of server, it doesn't matter. Only thing is, when you choose the server, you should run the same operating system and should have the same processor architecture. That is important.
Okay.
Yeah.
Okay.
Yeah.
Thanks.
Now, the big diagram, which depicts every component of rack, is shown here. In fact, this is okay, big diagram. Now you see there are two servers, right? And there is some shared storage. Just observe my mouse. Let me take the drawing tools. Right? So this is shared storage. This is one server. Second server. Right? So each server is connected to shared storage. Now on each server, we have local storage, right? So what is installed on local storage? The operating system. Means when you say server, every server, we install operating system binaries. Then Oracle clusterware binaries, Oracle clusterware is installed, right? So OS is installed, Oracle clusterware is installed. If you are using ASM, ASM binaries are installed. now together called as grid infrastructure. From 11G release 2, ASM and Oracle clusterware together called as grid infrastructure. Okay. Then of course you install database binaries, right, and created instance, okay, and started listener on every server, okay. Then as we discussed, services which implements workload management are created, and we are running service on node 1 and node 2, and the rack uses a listener is something called a scan, which allows applications to connect to the rack system. So the scan is introduced in 11G release 2. Earlier the scan concept was not there. So scan is basically a mechanism used by clients to connect to rack system. Okay. So we'll be discussing all these components in greater detail in future classes. But for now, just to give you an idea what is installed, what is configured on servers and the shared storage. Now if you see shared storage, on shared storage, what is their data? This is your database, right? When you create Oracle database, you create a database on the shared storage, not on the local storage. Then as I told you, Oracle clusterware also creates some files like OCR and voting disk files. You can configure ACFS, which is some advanced feature. So Oracle database files, clusterware files are created on the shared storage. Okay. So this slide summarizes all these concepts and shows you what is installed on every node, what is created on the shared storage. Clear? So being the first class, being the first session, let us stop here, and I can take any questions you may have at this stage. And just before that, let me show you, as part of this course, I am sure you have all the details by now. This is 12C. The course will be implemented using 12C software. You will be implementing the main 12C features like Flexi Cluster, Flexi ASM. We will be testing all those 12C specific things. And as part of this course, you will be getting some material also, like this one. This is theory material. I have two guides, theory guide and lab guide, hands-on lab guide. Hands-on lab guide will have all the various demos for every topic, and contains step-by-step technical instructions. For example, let us take one topic. These are all, okay, you have around 20, okay, 20 hands-on demos that will be implemented as part of this course. Okay, for example, let us take one topic called installing grid infrastructure, or okay, installing grid infrastructure. Okay, I just want you to see how this document looks like. This document contains all the technical instructions, what you need to execute and what you need to expect, along with the command and output. Step by step spoon feeding document. Once you have this document with you, you can install, you can configure, you can test everything on your own, because all these technical steps are thoroughly tested, verified in the lab, and documented in this format. Along with the screenshots, that shows what you need to choose, what you need to input. Okay, so this is what you get as part of this course. And the theory guide focus more on theoretical learning. Okay, more explanation about the theory behind the RAC system and all that. Okay, so you get a theory guide and hands-on lab guide. And this course is for 4 weeks. And these 4 weeks you will have online lab. I have VPN. I will be creating VPN accounts so that you can access your system any time of the day. You will have 24/7 access to the system for the duration of the course. Even after the course also, if system is available, you can continue to access the system. But for the duration of the course, the system is allocated to you only. Okay, 24/7 you can access anytime and implement, practice everything on the lab system. Just have a laptop with internet connection. That's it from your side. So with that, I hand over the session to you for your questions or any clarifications.
Yeah, hi Murli, Ravish this side.
Yeah, Ravish.
Yeah, Murli, actually, my purpose is to do Exadata certification because in my company, they need actually Exadata certified person.
Okay.
Okay, so for Exadata, I guess RAC knowledge is required, correct?
Yeah, mandatory.
Mandatory.
Yeah.
Yes. So if I'll opt for this course,
Yeah.
can I parallelly go for Exadata also? Because I guess from tomorrow onwards you are starting the Exadata also.
Yeah, tomorrow I am starting new batch of Exadata, but you cannot do it in parallel because to do Exadata first you should have completed RAC. Parallelly will not be
Okay.
possible. Maybe you can target
Okay.
next batch of Exadata next month. Once you complete RAC, you can go in sequential fashion.
Okay. And after completion of this RAC course, is there any certification that we can perform?
Yes, of course. Oracle has certification for RAC also. That is separate. I'm sure you know that process. You can
Yes.
register for.
Yeah, that I know.
Yeah, yeah. So RAC also
So
has certification.
so after attending this training, we are in a situation to clear the exam.
Definitely. Many of my students have cleared that.
Okay. Okay. Fine. Fine.
And I will help you. I can share some dumps with you, certification dumps. You can easily
Okay. Okay.
clear that.
Fine. Fine. Thanks, Pradeep. Thanks.
Sure.
Only I have a question.
This must be Saqib again, right?
Yes, yes, Saqib. Yeah, just wanted to know, like, 3 months ago, I had joined Euclid for Oracle DBA course, normal code DBA, and I used to, because I didn't practice in the lab at all. I always practiced on my personal PC. So isn't there a way to practice on my laptop, even RAC?
You want to practice RAC on your laptop? You can do that, provided you have minimum 12 GB RAM.
I have 8 GB.
16 is recommended minimum. 12 you can manage with 2 nodes.
Okay.
Okay, yeah, 12 GB. If you have, you can do it on laptop.
Okay, no problem. Because I don't, because with the DBA, it took me like more than 3 to 4 months to, to at least understand the concepts clearly. And I think RAC is going to be more complicated than that. So I think I will need more time than 2 or 3 months. So just because the VPN connection, VPN access is going to be only for as long as the course runs. Just kind of worried about that.
I'm sorry, as most of the okay, question I couldn't hear properly. Can somebody repeat this if you have heard him?
Yeah, Murli, his question is that the duration of course is 4 weeks. So the VPN connection that he will get is for 4 weeks or after that also.
No, no, no. You will have VPN connection. I will not remove that. As I told you, this 4 weeks, the server is dedicated to you. You will be given separate server. Each one of you will get separate server. Okay. All my servers are 32 GB servers. They have 32 GB RAM. Okay, and good hardware. And these 4 weeks, they are dedicated to you. You can play as you like. After 4 weeks also, till next batch is started. Okay, depending on how many join next batch. If server is free, you can continue to access that. That is, yeah,
Okay, I got it.
yeah,
Got it.
Yeah, Murli, I have one more question.
yeah.
Actually, I am dealing with the multiple databases in my company.
Right.
Okay, it is MySQL also, Postgres and Oracle also. So I attended Oracle DBA course means some 1.5 years ago, and I have a concept
Yeah.
of Oracle DBA.
Right.
So that is sufficient for RAC, or I have to go for DBA as well.
No, if you have already done, if you have idea on Oracle DBA, that should be good enough. Only thing is, if you forgot that, maybe you just refresh little bit.
Okay.
Okay, so otherwise, I don't recommend you to again waste money and time on that part.
Okay,
Yeah.
fine.
Mm.
Yeah, fine. Thanks.
Yeah.
Thanks.
Murli, one more question.
Yeah, please go ahead. Though I couldn't hear you clearly.
Okay. I think others can help me. Others are able to hear me, so they can, I mean, question you
Yeah.
repeat the question to you. Actually, I am in Saudi Arabia, and as far as I know, over here, apps DBA is, I mean, they have demand here.
Yes. Yeah.
Apps DBA is in demand here. So I kind of I'm confused a bit whether to go for apps DBA or RAC.
So what is your current skill is core DBA, right?
Yes.
Okay.
Actually, I quite recently learned it, so I'm kind of looking for a job now.
Okay.
But after coming here, I realized that they need apps DBAs more than they need DBAs.
Yeah, I know Middle East is full of Oracle apps installations. I know Oracle sales has sold to even pawn shops also in Middle East. Okay, so Middle East is full of Oracle e-business suite applications. Apps DBAs are highly in demand in Middle East. Okay, but see, technically, apps DBA, the database there also is Oracle database only. Okay, so
Okay.
RAC is useful for both core DBA, apps DBA, because it is part of the database. Whether it is apps database, core database, the underlying database is Oracle database.
Yes.
If you ask me, if you give that choice to me, I will learn both RAC as well as apps DBA if I am in Middle East.
Okay, but one cannot do them both together, right? You have to
Um,
do them one together.
yeah, you can do, because RAC and apps DBA can be done in parallel,
Okay.
but it all depends on you whether you can take up that, okay, absorb, practice, and effectively learn. Okay, if you are confident, I can do in parallel. Technically, you can do in parallel. There is no stopping. Only thing is,
Okay.
you have to see if you can justify that, spend a sufficient amount of time on practicing both the things in a day.
Okay. In that case, I'll have to think about that then.
Yeah. Otherwise, If you want to go sequentially, the suggested approach is rack, then apps DBA.
Okay. Okay.
First rack, then apps DBA.
Yes, fair enough. Fair enough.
Yeah. Yeah. Any more questions?
Murli, yeah, this is Ramesh. Yeah, this online training, these slides, can we store the complete class?